In this module 10, we will learn how to create drawings from part and assembly in SolidWorks. First we see what is concept of drawing, why we create 2D drawing in industries. Then after we'll look what is the overall structure of SolidWorks drawing. Then we'll try to create a part drawing. After covering the part 3, we are going to learn what is the importance of drawing template and sheet format. How can you use the benefit of this drawing template and sheet format to customize your drawing. And lastly, we're going to create assembly drawing, in which we are going to create 2D views of assembly along with the bill of material and balloons. Now basically 2D drawing is a way of conveying the vital information regarding part and assembly to the manufacturer. So SolidWorks drawing 2D presentation of 3D part and assembly. Now 3D models are designed not used by workshop because they do not have a computer, they have machine tools to manufacture the part. So you need to convey the information via drawings. So drawings are for manufacturing, inspection and communications. So drawing of part and assembly answer very vital questions like what is the overall size of a part, what is the tolerance, what is the material, based on material what kind of cutting tools required to use, and how it should be manufactured. So such informations and answer to such questions is available from drawings. Now drawing contain like important parameter like dimensions, notes, symbols with its 2D views of part of assembly. Now drawings follow basically engineering standards like ISO standard, American standards. So benefit of drawing is it automatically update when the 3D model changes. So they are associated with the 3D model. You can also change the dimension in 2D drawing and model will update. So this is the great advantage of SolidWorks drawing. Now drawing file is a basically blueprint for manufacturing. Now here on screen you can see it's a drawing of a spring clamp where you can see the front view, bottom view, top view and along with the side view. There are also detail views provided. Let's say this is A. So it is very small detail which is zoomed out in the form of detail view. Similarly, we have detail view B from over here. Same, we have a detail view from this part which is referred as detail C. Also, we have a section view that is taken from plane section DD. And orally, the dimensions are given to the part. So such 2D drawings provide very important question answers. What is the material? What is the part? Its name? What are the overall size? Tolerances? That's why they are useful for manufacturing. That's why it is required to create such 2D drawings. If you look at the structure for drawing file, now in SolidWorks drawing file have extension called .sld.drw. Now single drawing file has like this, for example, views, annotation. Annotation means dimension, notes and etc. Now apart from that, the drawing has sheet format in it. Now what is this sheet format? If you go in detail, sheet format is simply made up of standard paper size, or we call it standard sheet like ISO A4, ISO A3, ANSI B, ANSI A. These are the standard size of sheet. Also, the drawing has title block, border and text inside it. Now title block has vital informations which are simply connected with the property of a part and drawing, like at what date it is prepared, who checked it, what is the material, weight, revisions, and types of projections. So such information get updated automatically in title border block. So drawing file has three things: views, annotation, and sheet format. To create a part drawing, first you need to start new documents. If your part or assembly already open in background, then it will be very easy for you not to browse for that part or assembly to create the drawing. Or if it is they are not open, then you have to browse for the part and assembly to create the new document. Now after browsing the part or assembly, you need to create the views. For that you have to use the model view property manager. After placing few views, you can project the required views. Either you can create the three standard views. Now these three standards are front, side, and top. Now many times it is not sufficient to create only standard views. You may need to create sectional view to get detail inside the material. You may need to create the auxiliary views, detail views as we saw in the PDF file. You may require to create the remove section, broken out section, crop view, or for assembly you may need to create the alternate positions, which simply give overall idea about the movement of assembly. Or you may require to create the break view. After creating view, you need to apply the dimensions, or you can say other important things like nodes. So this is the overall sequence of creating a part drawing. We'll try to cover all of these through exercise. Now through exercise 10.1, this is our part. We'll try to create the views first. Later we'll add the dimensions. We'll also discuss how can you add the dimensions, what are the way of adding the dimensions, and then we'll switch to the creating the same drawings using the template available. Now let's start creating a part drawing. Now click on new icon. Now many times you may be presented with this interface, that is new SolidWorks document. This is simplified interface to create part, assembly, and drawing documents. Now each of these will utilize the default template provided by the SolidWorks. Now we can click on advanced and we can choose the template we have. Now at present under the template folder only 3 templates are provided, one for part, assembly, and drawing. Now I have added this Gunpers University template folder. Now to add that you can go to the options, and under the system options you can go to file locations, and here you can add your folder which contain your custom templates. Now let's create new drawing file. Now this time I will choose only default template and I'll continue. Because the default template drawing file is not associated with any sheet format. Now what is sheet format? Sheet format is sheet size and title block. So here it is shows that you just use the standard sheet size format. Now we are not going to explore this part. Instead we are going to create the custom sheet size, that is 420 by 297. Now purpose is to explore how to create various drawing views, standard views, sectional views, auxiliary views. That's why I'm going to choose the custom sheet size. We'll discuss in detail about the standard sheet size and template later. So click OK. Now let's cancel this. Now here what we have is in drawing 1, we have sheet 1. I can add as many as sheet I want. So right click and select the property. Here I can give the name to the sheet. Let's say test. Now here scale of this drawing sheet is 1:1. That means whatever view we are going to create will be presented with the true size of a part. Now we'll choose the first angle projection methods. Now because we have chosen the custom sheet side, so this is our dimensions. So click apply to take the changes. Now go to drawing command manager. Here we have model views, relative views and standard views. Now standard views will allow to create front, right and top at the same time. But let's explore the model view. Now here under the model view property manager, I have to choose the part file. So I'm going to browse that part file. So I will provide this file. So choose the angle base part. Now here we have configurations because this part file have two configurations. So I'm going to use simplified. Now I have options to create multiple views at a time, but instead I will choose only one view. Then I will project the rest of them. So once I place it, I can control the display. Normally the engineering drawing will have a hidden line visible. So automatically projected view is available. You can go up, down, right and left to create the respective views. Right? Now I will press escape. So here we have drawing view 1. You can rename if you wish to. Now let's choose this. Again, let's select this style to hidden. Now here it is written use sheet scale. Now what is sheet scale? Let's try to observe it again. Right click property. So let's make it little higher. So now the part is at true scale. Now let's click OK. So we have created one simple front view. Now I want to add few more, so I can use projected views. So let's go and pick the projected views. So this way you can simply drag and place the views. Now let's go and delete and try to add few more. Now let's add auxiliary views. So auxiliary views are best suited for to see the true shape of inclined surfaces. So over here, this surface is inclined, hence its top view and side view are not going to give you the true size and shape of a circle. So there the auxiliary views is important. So this way you can simply choose and drag and to place it properly. If you want to place somewhere, so go to right click and break the alignment, so you can place it somewhere like this. Now let's click and delete it. Now I want to create a sectional view. So here when I click it, I have options to create the vertical section, horizontal and incline. Now I'm going to create the vertical one. That means I am able to create the sectional side view, either left or right. So let's place over here and right click. Moment I right click, it shows me that I exclude a feature from the hatching because this is the rib features. So by engineering standard, rib should not be hatched or should not be considered under the section. So I have to choose this and click OK. So here I have section side view. Let's create the sectional top view. So click again. Now this time horizontal and let's place over here. And right click. Again choose this rib and click OK. So this is sectional top view. So sectional views are very useful to see the intricate detail of the component. Now let's go ahead and delete all of them. Now let's create the detail view. So here let's say I want to see the detail of some corners of component. Let's say this size. So here I will choose the detail view. Here I have to draw the circle. So moment I draw it, it will simply create a view which is at little larger scale. So we can see the minute detail at a zoomed out scale. This is the purpose of detail view. You want to edit the circle. So just pick and make it larger. So just drag the circle to resize the zoom view. Now here the scale is written. So let's right click and try to edit the feature. So here I can change the scale. Let's say I want to make it, instead of double, let's make it 4 times. So you can see the minute detail at a larger scale. And this is the purpose of detail view. Now let's try remove section. Now what is the purpose of remove section? It basically give you the insights. Let's say you have a pipe, right? Now you want to provide the circular section, because that way you can have an idea what is the cross section of a part. So let's select the opposite line and place somewhere over here. And let's click the refeatures. So here what we have is called remove section. So we simply cut the part at this location. After removing, we are looking at from that side and we are going to create the section. So this is called remove section view. Now let's create one more projected views like this. Let's align it. Now let's create the broken out. I will discuss standard view later. Now let's start with the broken out view. Here I will draw a region by defining the, now here I have to provide the depth. So depth is counted from the farthest edge. So from here it is counted. So here it is default value is 10. So look at the 10 value. So from here it is 10. Now let's increase the value. So just look at that yellow line that moving up, and based on that the section preview is changing. So you can just define or simply yourself select over here and provide the distance by selecting the edge and click OK. So here we have broken out section. It simply remove the part of material to see the inside detail. Very useful if you have a very internal features in a component. Now let's try break view. Basically break view are very useful for slender component whose cross section is much smaller compared to its length. Like a road bar, let's say you have a length of 1000 meter and the cross section is simply 20 millimeter. So it is very difficult to place such component because side view is very much smaller. So in that case you are going to provide the cut. So let's apply break over here. Now here I am going to place from here to here. So it simply reduce the size of component. So here we have provided the break. You can have a vertical, horizontal, you can have a different style. So it is suitable for a slender component. And in this example, it is not suitable. But I have demonstrated how to apply the break view. Now let's go for the crop view. Now before that, I need to draw the sketch. Let's try ellipse this time. So here I am going to draw a sketch. Now let's go to drawing command manager and choose the crop view. So what it does, it simply keep only that part within the region and remove or simply crop out the other part. So it simply highlights some part of a component. Now alternate position is applied to assembly. It is not applicable to part. Now predefined views are basically useful for creating the drawing much faster. So where you are defining the position of front view, side view, top view and save them in template. So you can create the drawing very quickly. We'll see all of this in template creation. Now let's try the standard views. So click on it. Now standard views, as its description says, that you will able to add front, right, top at the same time. So let's browse same part, angle, base part. Now what it does, it simply draw front, top and right at the same time. So it is much faster. So it saves our time. So same can be done by using predefined views. You can add the isometric views and other things. So let's try to add the isometric view. So go to model, next, and choose this one. So here we are going to put the isometric. You can also change the style. Now let's go for hidden detail. So this way you can utilize the 3 standard views. Now here, let's delete this part. Now let's try to add the dimensions, because engineering drawing without dimension make no sense. Now remember, I do not have any title border or title block, and so I'm just trying to demonstrate how to give the dimensions to the part. Now go to Annotation tab. Sometimes you may have to use these smart dimensions to give the dimensions which are not available through model item. Now what is model item? While creating the part from the sketch, we provide dimension to the sketch, that is length, height, radius, and so. We also provide dimension in features, let's say extrusion depth. All these dimensions are important. So those are referred as model item. So while creating them, we can use those dimensions, which is 90% or majority cases it is true, which are representing the actual dimension of this overall component. So my purpose of this video is to demonstrate how to use the model item. You may find that some of the dimensions are still missing, then you can use the smart dimension to add them. So click on model item, select the entire model. Now here it is written that import the dimensions which are marked. Now what is this mark? So let me show you. Let's open this part. Now let's say edit the sketch. Okay. Now when I double click it, here it is shown over here. So this dimension is marked to import for drawing, because we require these dimensions, right? If you press this dimension will not be available as a model item in drawing. So by default, it is always marked dimensions in modeling process. So let's go to the drawing again. Now let's select the source entire model. Now here you can give the dimension to selected feature, but we want to apply dimension to entire model. What you can import is all the dimensions which are marked. We can also import the callout, number of instances used in circular pattern or the linear pattern, and so. If your annotations contain or part modeling contain any such notes like surface symbols or the node, you can also import it. Now here what we have is one checkbox, use dimension placement in sketch. Now what it says, when you place the dimension in while sketching and creating 3D model, their location from the edge will be maintained. So same position, same placement of a dimension in a sketch will be placed over here. So let's go ahead and click OK. So imagine, so this 159 in model actually this much far away. Now here, let's separate little bit these views so we can have some space. Now select all of this. You have a small dialog box, just move over here and choose auto arrange dimensions. So that will ease our little work. Now here you may need it to arrange these dimensions. If they are overlapping, then you have to move little bit away to avoid some problem. Now let's add one more drawing views, which is auxiliary views. So here choose this and click over here and click OK. Now because it is in awkward position, let's break its alignment and take it over here. Now I want to bring this 95 dimension to over here. So choose it, press shift and drag and try to leave on over here. So it is shifted to a proper view, right? Similarly, you can move this 16 dimension, select it, press shift, then drag. If you press Ctrl and drag, it will going to create a copy of a dimensions. Similarly, you can just adjust the remaining dimensions. Let's say, for example, this is diameter, then over here you can choose this diameter symbol that will add. So this way, let's say I want to change the precision of these dimensions. So instead you can go for none. You can customize in this way. Always try to arrange the dimension in a proper way. Make sure they are in between the views. Let's say, let's transfer this 76, press shift and over here. So it is visible to you. Press shift, select and over here. Now all of these dimensions are black in color. That means they are driving dimensions. Let's say if I double click it, if I change it to, let's say 180 and rebuild it, you will see the part length has changed. So these driving dimensions are having bidirectional associativity. So from here you can change the dimension of a part. So let's undo it. Again, just relocate the dimensions to avoid any conflict. If you feel that some of the dimensions are improperly placed, then shift and drag to place it to the proper view. Like this. Okay. So this way you can import the dimensions to your drawing. Now let's say out of these dimensions, still some important dimension is not available. Then you can add from annotation and using the smart dimension options. So let's try. Let's say I want to give the length of this. But here, look at very carefully, it's in gray color. So it is driven dimensions. By changing this, you cannot control the geometry of a component. They are simply for display purpose. So that's why under the annotation command manager, smart dimensions are given, because sometimes your model items are not sufficient to convey the vital dimensions or informations. So in that case, you have to add through smart dimensions. You can also add the note. Here you can use the, let's say, for example, this part must be machined from bottom first. So you can simply provide informations through notes. Here you can also add the whole call out. Now let's click and choose these informations and add it. Now see, these dimensions from the holes are gray out. You cannot change it because it is governed by the feature itself, which are standard holes. So you have to change the hole features, then automatically this will get updated. Now sometimes you may require center mark and center line. Let's say I want to add the center line. So click on two parallel surfaces. It will add the center line. It is much easier. Now let's add the center mark. Again, it's a very simple. You need to select the arc or circle, and that will add the center mark. Now, again, based on your drawing, you can add the other symbol like welding symbol, surface finish, geometric dimension tolerancing. And now let's close this file. Now this time I'm going to create a drawing by using my template, custom template. Here I will choose this ISO A4 drawing sheet. Now what it does, it simply provide me sheet size, which is A4 as it is written over here. Along with that, I have a title block and border. Also, along with that, some informations are added. Now let's click OK. Here again, before I add the part, look at the title block. Here I have a title. Now it is called draw 2. Now this name is drawn from the drawing file. Moment I save and I give the proper name, it will appear over here. Second, drawn by means this is the properties which is given in the drawing file. I will show you how to modify such properties. So all this information will get populated. Here there is a material. If I add the part to which the material is already assigned, will be displayed over here. Along with the weight is also displayed. So let's click and try to choose the part. Here I only will place the one view. Clear? Now see, the part is made up of plain carbon steel, right? Now because I have added the part whose name is directly taken to the drawing file, its name also appeared. Now how this appeared, that is my name. So let's go over here. Here I have under this property, under the custom, I have already added the author, which is custom property, and my name. Now this is linked to that property, and that is done through template creation process. Now here look at, when I add it, it simply draw the vital information regarding the part, name, who drawn it. At present it is displays at a 1:2 scale, and the material. Now here, okay. So such templates are very useful to provide the ownership to the drawing through title block informations. Now see, here I do not have weight. A weight is not populated. How can I add it? Now let's open, because these two properties are drawn from the part. So we need to check whether it is applied to part or not. So click over here. Here only I have added material. Now let's add the mass. Select the weight, and from here choose the mass, and it will get populated. Let's click OK and save this part and switch to the drawing file. Now see, it shows the weight. So here the weight property is connected with the part weight. So moment we change this, it reflects the actual weight. Now let's open the part again. Now this time I will change the material from plain carbon steel to copper, and I will save it. Now I'll go back to the drawing file. So here see, the name is also get changed, and also the weight. So such custom template is very useful. That's why it is recommended that you use your own custom template, but make sure to add in system options. So over here in system options, you have to locate your folder. Now remember to maintain the safe storage of such templates, because you may format your computer system, then you will get completely remove all the templates. So better you save on network drive or some other places, safe places, so you can add later. So you can add multiple folders based on work. Now here I have A4 portrait ISO. Now here the same thing, but the logo having a different institute name, right? This is landscape. So it's very useful to use the template. Now again, in template you can also customize by adding the predefined views. So moment you choose the part, is 3 view get added. You can also import the dimensions to those predefined views. So we'll try to see all of these in template creation. Now let's try to replace this part. So select this, replace the model. This time I will choose the support and click OK. Let's rebuild. See, the new part has material called 66 alloy and its weight is populated. So this is the benefit of using the template.